Today I want to talk about floating walls. So there's a lot of videos out there about how to float a wall, and so I want to talk a little bit more about a little bit more advanced things such as reverse floating, what to do with doors, and what to do with cabinets once you have everything finished off. Because a lot of places tell you how to float walls, but they don't tell you some of the other things that you have to do in order to get everything to work together. So first off, I'll talk about floating in general. So the reason you want to float walls is because a lot of places have expansive soils. Not a lot of places, but some. Colorado being one of them, which is where we're at. And so what you want to do is basically make it so that if the floor moves up and down, so let's take this area for an example. If the floor starts to move up and down, it'll slide up and down on this pen, and the wall will stay completely straight. The reason for that is because if this wall is connected at the bottom and the floor starts to surge, it'll basically push the force up through one of these members and up into the rest of the house. You don't want that to happen because then you'll get cracked floors, you'll get cracking on countertops, all kinds of fun stuff. So it's really meant to protect your house. There's some places that'll say you don't need to float around the edges of the walls because that means your entire wall would be moving anyways. I went ahead and did it for all my walls. One, because I'm offset a little bit. If you look at that white stuff behind the framing, that's insulation. So there's a gap between my main concrete walls and the walls that I put up. Also, just so I could connect everything and everything worked as one instead of only floating the stuff on the inside. So recap, if you haven't seen anything on how to float walls, it's not too hard to do. You need a bram set or a drill with some concrete screws. I tried that first, didn't work too well, so I went to a ram set, worked pretty well. So basically, you set a plate down at the bottom, which is this one down here, and you make sure that it's in line with the wall. I used some liquid nails at the bottom, got it set in place, and then use a ram set to basically nail it to the floor, to the concrete floor. Once you have that in place, you can build your wall. Depending on the code in your area, you need a different size gap. The area I'm in needs a 3-inch gap, so you need to build your wall so that there's 3 inches extra between your wall and your roof. So what I did, built the wall, and then basically put 2 2x4s underneath it and set it on top of those so that it's in line with the plate at the bottom. And then get everything plumb, get your level, make sure it's level all the way to the top, and then just screw it into the rafters. So you can see I use screws, some people use nail guns, but each rafter has a screw put into it. So that's the gist of doing a floating wall. Now, what I really want to talk about here, so some of the problems I ran into. So you have to think about what I said earlier is if you're trying to avoid any force transfer from the floor as it moves up into the house. So you have to have some gap somewhere. Well, when I went to install a bathtub, which is behind this wall, you can see down at the bottom, it is right up against the floor. So if I were to go ahead and screw that, which it connects to the wall all the way around, you've basically eliminated that float at the bottom, and you've connected the floor back to the joists, which connect back to the rafters. So what I ended up doing for this wall, if you can see, I did a reverse float. One thing I should have done, which you can see I did not, is put another plate here, and that way when I put some trim or molding here, I could connect to it, because that's going to be a flat wall there. So a reverse float's the same thing, except you connect everything down to the bottom. I already had a plate down there because originally I'd floated this wall, I had to cut it all down and redo it. And basically put the nails up through the top into something that's screwed up into the rafters again, as you can see up here. So that's all there is to reverse float, and so the idea here is this time is if the floor moves, the entire wall moves, but again, it has this gap so it can slide up and down along these pins and won't actually push the forces up into the rest of the house. All right, one other thing that I ran into is doors. So I have a couple doors over here. And originally I had framed them out to be a typical sized door. The problem with that is once you put your door in, it's pretty close to the floor. So again, if the floor starts surging, you can basically trap your door in there. Now, some people say don't worry about this because you can open your door. But it's just an extra precautionary measure that I lifted. I went ahead and cut the plate off of the top so that the door is going to sit up above the ground. And what I'll do is at the bottom of the door, put some type of sweep or something so that you don't see a huge gap at the bottom. But then it'll be in line with what I have here. This is a sump pump room that I'm looking at. So I did that on all the doors. You can see a couple of doors here and here. This one's going to be a little interesting because it connects to that wall that's reverse floated. So I'm going to have to basically try to keep it from connecting, have some pins in there so that if this wall slides up and down, the door doesn't get cranked inside of that opening. The last thing is something I can't show you yet, but something that people don't think about too much is once you have everything finished, you have all of your sheetrock put in, etc., painted, and you want to go in and put in cabinets. A lot of cabinets mount to the walls. Well, you're going to have the same problem where if you have the cabinet sitting on the floor and you mount it to one of these walls, it's going to do the same thing. If you have it mounted to the floor and it's screwed into the wall, it's going to eliminate that float. And if that cabinet starts moving, it's going to start moving the wall again. So there's a couple things you can do to avoid this. One is don't connect your counters to the wall, but that's a little dangerous. The other thing is there are floating cabinets that you could get. Basically, they screw into the wall but have a gap underneath. I don't like that because you get a lot of stuff trapped underneath. The other thing you can do, and this is something that happens in log houses, is you can basically add a small piece that has an opening and an insert so that if the cabinet starts going up and down, it slides up and down inside that piece, but it's still connected up against the wall. I'm sorry I don't have an example of that, but that's just one of the ideas. But something to keep in mind, anything that you are mounting to the floor can't be connected to the wall in this type of situation, or it's going to just basically get rid of that float that you did. So that's all I have. Just wanted to go through that real quick. I didn't see too much about some of those other things on YouTube, so I wanted to add some information about it. Welcome any comments. I'm sure other people have done other things, or some people have said, you don't have to worry about some of that stuff, you're overthinking. But there's a lot of stuff that is precautionary, which is what a lot of codes are based on. So I just want to go over that. So thank you for watching. Have a good day.